Okay? If we break it down, the per mathematically means divide. What does the cent in reference to? 100. So really what we're looking at is an amount divided by 100. So it's the amount in 100 units of that sample. So that if we went through and did, say, I don't know, the number of people, it doesn't work here.
You can do that.
We don't have 100 people here. What we're looking at is, say, a random number. So let's say 40 people out of 100. Okay, what would that result in for our calculation? Because we have the per, which is our divide. We would end up with an answer of 0.4. Okay. Well, what are our units on that? Well, the 40 is people. The units on 100 was our total number of people. So what happens to the units when we do a percent? They cancel. So we don't have any units. We just have 0.4. Okay. Well, 0.4 what? We're talking about percents. Okay. Percent means out of 100, okay, or out of our standard 100 units. So we need to bring in that unit. We can do that by adding an extra step here. We can multiply by 100%. And you might say, well, isn't that now doing an extra calculation? But what did percent mean? Divide by 100. So when we multiply by 100%, what are we multiplying by? 1. So it's not really changing the meaning, but multiplying by 100% gets us what? What does it introduce? A percent sign, our unit. If we do that multiplication, what does our answer become? 40%. Okay. So we can now introduce a unit of percent into our reporting, or however we want to look at this. So we're looking at the number of a sample, or the number of a species over the total sample. When we multiply that by 100%, we would then have the percent of whatever our measurement is. Okay, so that's our basic calculation on determining a standard percentage. Okay. One of the issues that tends to pop up is that we end up not being very clear when we ask you to calculate a percent. Okay. If I ask you for the percent water in someone's water bottle. Okay, so percent water in a water bottle. What do we need to be looking at? Okay.
Total volume.
I heard a suggestion.
Oh, okay.
You're right.
Okay.
Well, that's my water. That's my bottle. It looks kind of like a flask, but that's a bottle. Okay. I heard a suggestion for the percent water by volume. Okay. So what would I have on top?
Water current in the bottle.
I want a little bit more than water.
Volume of water.
The volume of water. So what
volume.
unit would I be using for my volume?
Million.
Typically we'd see milliliters. Why milliliters and not liters? Liters is our core unit.
Depends on how big the...
Depends on the size of the container. In a chemistry class, are we dealing with liter volumes? No, too toxic, too dangerous. We switch to milliliters. So we would probably use a milliliter volume. Okay, what are we going to then divide by?
Complete volume.
The total milliliters of what? If we do water, well, there's only that much water.
Then it'd be 100%.
What the water bottle can hold. So it would be the total milliliter volume of the container. And if I wanted this to be a percent, I'd then multiply by my 100%, and we'd have our answer. Okay? So I could measure it as a volume. Is there another way that we could determine how much, or measure the water being in that bottle? we don't have some equal sized bottles here to start swinging around. Okay. If we say thank you, Jessica's bottle, and then you got hit with that, okay, that might hurt because of the mass of the water in there. But what happens if we switch it up to, of course nobody's bringing out a metal bottle. Okay, I like the glass one. We started swinging around the glass one. And if we look at the volume, those aren't too far off as far as the amount of water in them. Which one's going to hurt more? Why is the glass one going to hurt you more? Let's assume we don't break the glass. Don't add that variable into this.
It's just blunt force trauma.
Blunt force trauma. It's just blunt force trauma. Why is the glass one going to hurt more?
It's heavier and it's denser, more rigid.
Heavier. Is measuring the volume going to help us? No. How else could we measure a percent of water in our bottle?
Mass.
By mass. We don't want to use weight. Weight is gravity dependent. We have to use mass. Okay, so I could have gone through and calculated via the mass of water. And I don't know why I put GM, because water is spelled with a W. Grams of water over the grams of the entire container. Okay? It's not just the container, though. It's also the water in said container. It is the total mass. Okay? And then I could multiply by 100. Am I going to get the same result? Am I going to get the same percentage? No. One case, I'm looking at the volume. I don't care what the mass relationship is. Right? In the other case, I'm getting a mass relationship, and depending on how heavy the container is, maybe I get a very large percentage or maybe I get a small percentage. So why would I use one over the other?
Depends on what you want.
Depends on what I'm being asked for, what units I'm looking at. Typically, when we look at liquids, we'd be looking at which percentage? Mass or volume? Volume, because how do we measure our liquids?
These liquid occupies the space.
Solids occupy spaces too. Why do we typically measure our liquids with volume? There's a couple big answers. That's our standard measurement device for those. What is our standard measurement device for mass? What do we use?
Scale.
The scale, or our balances. And our balances are electric. What happens when we spill a liquid on our electric balance? It ruins it. So we end up dividing our liquids and measuring them based on their volume instead of on their mass, because we don't want to ruin our balances. But what if we're measuring a solid? Okay. The mass of marbles that we put in, the amount of marbles that we put into a container. Measuring the volume, could work. They are occupying a volume, but more than likely what's more relevant to that comparison? It's probably a mass. Okay. So our percent can be dependent on mass or volume, and we should actually be very, very clear when we ask the question. Determine the percent by mass, or determine the percent by volume. What if it's not inherently obvious? Okay, let's see if I did a good question here. Okay, so we've got a question here. Bronze is an alloy of copper and tin, which is going to be relevant for the question. If a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin, what is the percent copper in the bronze? Okay, so that's our first question. Percent copper. Am I asking for mass or volume? Does it say? No. So how do I know what I'm supposed to solve for? I could do a rhetorical analysis of the information provided in the rest of the text. And the rest of the text tells me what? I'm looking at grams, and grams are a measurement of mass. So the information provided to me is giving me textual clues telling me which one I should be solving for. That wasn't too bad, right? Yeah. So we should probably be solving for... You guys should have all been amazed. That was awesome. Yeah, that was pretty impressive. You're just doing it because he told you to now. What is the percent by mass of copper in the bronze? Okay? For those of you who didn't get it, don't worry about it. Not a big deal. I thought it was cool. Small victories. So, what are we asked for? Percent copper. Okay, well, yeah, I can write that out. Percent copper in bronze. How do we set up our calculation? Okay, and we decided that it's probably the percent by mass. Okay, so if we go up to how we calculate a percent, it's our one quantity. What's our one quantity going to be? What should we have in the numerator?
100 grams of bronze.
We want the grams of what?
You said what we're taking it from?
Copper.
Why do we want the copper?
Because we have the bronze.
Well, we have the copper.
Because that's what you're asking.
Percent copper. Percent copper is the thing in top, which means what should I put as my unit on top? Copper. The mass of our copper. What do I need to put on the bottom? The total mass. Okay, the mass of the bronze sample. Well, what is my total mass? Okay. It's the combination of the copper and tin because I'm told that's how we make bronze. So I now have to add those two values. It would be 79.2 grams plus, what was the other one? 10.8 grams. And we now have our grams of our bronze alloy. Okay. Our grams of copper was what? 39.2. What do we have to do as our last step to get a percent?
Times by 100.
Times by 100%. Okay? Questions? Yes.
That next question is how much tin is it on?
We'll come back to that. Are there questions about the methodology that we just came up with for that?
If you were trying to just find out how much copper is in bronze, wouldn't you be pulling away from bronze instead of the copper itself?
Wouldn't I be pulling what?
You're pulling away the copper from the bronze, right?
So
asking
79.2 grams of copper has been pulled away.
from 100 grams of bronze.
How do you know it's 100 grams of bronze?
That's the second question.
That's the second question.
Oh.
That is a new question.
Oh, screw it. It was my reading then. I'm sorry. Yeah.
Okay, so we have to be careful and answer only the questions directly given.
Okay.
Okay. So is everybody okay with that?
Yeah.
When we go through and get that, what do we get as an answer?
90%.
We get a percent. Good answer. I think if we do all that math, I'm going to guess it comes out to 88.0%.
Did you really miss that?
Yep, 88.
I think that's right. I'm good? Okay. Yeah. See what I did there?
Okay, so I said no. I get it.
Okay. So it should come out to 88% what? Just percent? Percent copper. Okay. So that should be useful information, because we'll erase everything away. Our first answer said that we had 88%. Oh, I shouldn't lose my sig figs. 0.0 copper in the bronze. What's the next question now asked? Okay. I want to know how much tin. Okay, so what do the units on my answer need to be? Grams. That's it? Just grams? Grams of tin. Okay. Do we have a conversion factor that brings grams of tin into play?
Yeah.
Where's that conversion factor?
It's the percent, like, sorry, so.
Work through it, because you're right.
No, I mean, if there's 79.2 grams of copper and then 10.8 grams of tin, which is general bronze, then you would just kind of like find what 10.8 grams of tin is to whatever the mass was in the original. Sorry, I added it to 80% or 80 grams. So you just replace copper with tin in the numerator, and then when you find that out.
Right?
I could be wrong.
There's nothing wrong with this. What do we end up generating here? We'll end up with a conversion factor that relates the grams of tin to what? What's the unit for that bottom number? grams of bronze. If we can ditch the percent unit, we can now bring that conversion factor into our equation. And we want our grams of tin, 10.8 grams of tin on top. Why do we want the grams of tin on top? That's our answer. It needs to be on top. That is then related to the grams of bronze. Anybody do that calculation? Is it 90 grams? 79.2 plus 10.8
Yeah.
is 90. I just did that calculation. So this right here is this. No? Yes? Yes? I'm asking. Okay. Is this in black the same thing as what's in purple? What's wrong with it?
I'll say the percent
Oh,
of
no.
tin. is-
What's wrong with what's in black in comparison to what's in purple? What does not match?
The bronze is actually.
Grams of bronze. What needs to happen to the units of grams of bronze? It must cancel out. So ideally, I would then go back up into my question and say, am I given, bronze has a, I need to find the mass of bronze for this sample. Am I given the mass of bronze?
Oh, yeah. So
It's given me explicitly in the question. 100 grams of bronze. What am I then multiplying that by? The decimal value of my percent. What happens to the units? And what would we have? Grams of tin. We've got our answer. That is absolutely correct. That involved running an extra calculation. Okay? The other method does also involve an extra calculation. What is that other method that maybe you were going to suggest, Natalie?
Using a percent, right? So you could just take like the 88 or 100 minus 88.
100 minus 88.0% copper is going to result in what? 12% tin. Whoops, shouldn't do a capital N. How do you know that? It has to equal 100%. Okay. If I go through and do the 10.8 divided by the 90, guess what I get? 12.0%. It's there. Depending on how I see a path through it, I can solve it in two different ways. So your way, awesome, Alex, it worked.
no, I was trying to say what she said.
Oh, you were?
Yeah.
Oh,
I
well
was
then.
explaining it to that. So
Yeah.
I'm just confused.
Well, you're not confused, it worked. Everybody see how we can go through and work with those percents. It's still the same methodology we've been using. Find out what unit you want to end with. Set up your conversion factors. What does the percent provide? A conversion factor. That's it.
How do you know that second question was asking specifically for a percent and not just like
The second question isn't asking for a percent.
How much tin is in 100 grams?
It's how much tin. So what did I get as my final answer?
12%. So 12% of 100 is.
My final answer was grams of tin. Didn't ask for a percent. If I'd asked what is the percent tin and 100 grams of bronze, well then is it relevant to say 100 grams? No, it's completely irrelevant to the question. Because I could have just done the calculation outright. I got 12% without using the 100 grams. Okay. So if we're being asked for how much, that is now defined as a mass.
What if it said how many grams of tin is in 100 grams of?
Bronze? You mean what we just solved for?
With not into percentage though. So would it
It's not a percentage. Look at our answer. It's grams of tin. There's no percent.
Yeah. So.
What did we need to solve that? We needed the conversion factor between grams of tin and bronze, which is
12.
the percent.
Yeah.
So you needed the percent to solve the question. Okay. It's a step along the way. The percentage is just a conversion factor. Okay.
It's because there's 100 grams of bronze. That's the same.
So what might be confusing is you're seeing the 100 grams and you're saying, oh, 100 grams is 100%. Is that true?
No. It's
No.
12% of 100.
So the 100 grams may be confusing. What if we change that to 350 grams. It's still 12%, but is that the amount of tin in 350 grams? No, what do I need to adjust? It needs to become 350 grams there. Make sense? Oh, so good question. The 100 minus 88, what is that 100? That's a percent. Why is it 100 and not some other random number?
Because 100%.
You can't have more than 100% of something. That is your maximal value. Why do we know we can just subtract the mass of the copper? Well, we're making an assumption. What is that assumption? Bronze is made up of only copper and tin. So there's only two things there.
And are we also assuming that always 88% copper and always 88%?
For bronze, yes. We do have to make that assumption for bronze. Because if it changes, then you have to resolve everything. So you do have to make that assumption that bronze is always that percentage. Yes.
So for the second question, just because it's 100 grams of bronze, there's 12% of tin. That also means that there's 12 grams of tin. Just because it's 100.
In a 100-gram sample, yes.
Easy question.
Yep.
Simplify.
So I should change that number for future classes.
Yeah.
When it comes to volumes, we real quickly went through volumes. Volume, how do we calculate volume? Length times width times height. How do you measure length?
The ruler.
With a ruler. It's a distance. Okay, so we could get units of meters or centimeters or millimeters. Okay, how do we measure width? Same thing. Centimeters, it's a distance. Height, same thing. Centimeters, it's a distance. So when we look at our general volume shape, we can do that off of standard measurements. And we did that theoretically in, say, a trig class or a geometry class. Okay, we could determine the volume of, say, a square. But what happens when that square becomes non-standard? Okay, and moves to an irregular shape, say like a liquid. That becomes a lot more difficult to measure the length, width, and height of that object because the liquid starts to deform to whatever container it's in, and we'd need perfectly sized containers. So what did we end up doing? We invented a new unit to measure volume. That new unit is a liter. Okay? Because we invented it, we could define what that measurement was. Okay? The liter is defined as a cube that measures 10 centimeters on a side. So that if we go through to set up our length unit for volume, that is an actual fact.
Okay, cool. So I never knew that.
Yeah. So we take 10 centimeters is our length times 10 centimeters, which is our height. I just wanted to be a jerk. Didn't matter. 10 centimeters times our width. This then has to equal what?
1 liter.
1 liter. That is our definition. And the computer's trying to connect. Equals 1 liter. Okay. So we have to complete the calculation on the left to set up this unit. So what is 10 times 10 times 10? 1,000. Okay. What is the unit on the left? That is now centimeters times centimeters times centimeters, which equals centimeters cubed. This then equals 1 liter. For those of you saying I don't like cubes, which I think I heard, I agree with. Oh, you liked cubes? Oh, well, I didn't like cubes. I think the cubes always mess with things. Okay. And we now have a conversion factor between a distance measurement and a volume measurement. Okay.
So you never say like 10 to the 3 centimeters.
You could say 10 to the 3rd centimeters or 10 to the 3. It's probably easier just to say 1,000.
Right.
Okay. So then let's bring in the next kind of deal. Use your metric conversion skills, and I want to know the unit factor for centimeters cubed to milliliters. Mm-hmm.
So wait, so milliliter would be...
So what I'm looking for our final answer is centimeters cubed in the numerator and milliliters in the denominator. do I know any relationship between a distance measurement, okay, and a volume measurement? Yes, what was that measurement? 1 liter was 1,000 centimeters cubed. Which unit do I want to see in the numerator? Here. So we've got 1,000 centimeters cubed equals 1 liter. How do I incorporate that conversion factor into my expression? Where should the centimeters cubed show up? In the numerator, because
That's where it is.
that's where it shows up in the answer. It's close. Which means
That the milliliter is at the bottom.
Which means there's no milliliters on this page, except for our final answer. The liters need to show up on the bottom. What number shows up in front of centimeters cubed? 1,000. What number shows up in front of liters? 1. Is that my final answer? No. What do I need?
To get it to milliliters.
I need to get rid of liters, and ideally I want milliliters. How do I do my conversion? I need to know what milli means. What does milli mean? Say that again. 1,000th, which means 10 to the negative third. Remember, our power of 10 always affects our core unit, which is liters. 1. And this comes out to be what? It's 1 over 1. Give me 50 cc's of, I don't know, some steroid, stat. What are they referring to when they say cc's? Cubic centimeters. They could have just as easily said milliliters. They are the same. They directly convert across. Yeah. You are free to use that conversion. If you want to be able to convert between centimeters cubed and milliliters, do you have to go through and show all this work I just showed?
Yes.
No. You can just say 1 centimeter cubed is 1 milliliter. What's the issue with that? What happens if you don't remember that conversion? Then you're screwed and you might actually have to show the work. Right? You are officially responsible for the first one, the 1,000 centimeters cubed is 1 liter, because that is what defines a liter. From that, you should be able to convert across. Okay? So with that, do we need to do this one again, or do you think you guys got that last time? That was a yes or no question. Did you get this conversion last time? I heard a no. Still a no? Okay. You're going to do it. Start. What we want to get, we want inches cubed. Every single time, that is where you need to start. You have to know where you're trying to get before you start your mission. Okay? What's the next step? What we're given. Okay, we're given 498 centimeters cubed. Is centimeters cubed the same thing as inches cubed? No. So what do we need to do? The conversion factor. What do I want to convert? Centimeters into inches. What is that conversion factor? 2.54 centimeters is 1 inch. Okay. Would that give me my answer? We're going to do it cubed, right? Okay, so I'm going to point this out because I addressed this on Thursday. And everybody's like, no, I totally get it. Well, it needs to be cubed. So now I go in and punch it into the calculator. And sorry, guys. Brandon, Natalie, what did you guys get for an answer? 196 inches cubed. How many people got that answer? Oh, come on. Really? You guys aren't very nice. Okay. What's the mistake that was made within that? The conversion is 1 inch is 2.54 centimeters. Not 1 inch cubed is 2.54 centimeters cubed. So if I want to cube or end up with cubed units, what do I have to do? I have to cube the whole thing, which means, drawn out, this is 1 inch over 2.54 centimeters times 1 inch over 2.54 centimeters times 1 inch over 2.54 centimeters.
Isn't that already what it says?
Coming down to an interpretation of what it says. As written, that is exactly what it says. As it is typically written, that is not at all what it says. Now that cubed is only applying to the unit, it's not applying to the number. To apply to the number, you need the parentheses.
So what would it mean without the parentheses? I mean,
It's 1 inch cubed is 2.54 centimeters cubed, which isn't true. That's not a valid comparison. 1 inch is 2.54 centimeters, not the cubed form of it. Okay? So it comes down to what you enter into the calculator versus what you write. I will still get students writing everything correctly for the math and then still tell me 196. Because what did they do? They didn't recognize the cube has to apply through to the number. You have to run the calculation 3 times. If you're one of those people that is not applying the cube correctly, write it out for every single unit conversion. You need to show it each time. You show it each time, your number then changes pretty drastically, and it's not 196 inches cubed, it becomes, what was the number?
30.3898.
30.3898. Okay. And yes, I hear you guys shouting sig figs. Right. So now we can address that. Our calculator spits out that number. We'd still be wrong, though depending on the point in the test, that may very well be an answer choice. Right. What do we have to correct now? Our sig figs. To address our sig figs, we need to go through and look at our conversions and say how many sig figs were each in conversion. In that very first step, how many sig figs? 3. And the next step. Pause was a good one. That's a good one. It's infinite because our standard Bureau of Measurements, there's some fancy name to it, I don't know what it is, defined 1 inch to be 2.54 centimeters. That has an infinite amount of sig figs. 1 inch is exactly 2.54. Okay? Which means our answer needs to have how many sig figs? 3. I can start at the left and underline. The 3 becomes significant. What about that 0? Should the 0 be a significant digit? Why is it significant? There's 2 reasons. The surrounded by, I would argue, is irrelevant. The surrounded by is only relevant if there's no decimal point. Do we have a decimal point? Yes. Since I have a decimal point, what do I need to do? Look to the left. Do I have a significant digit? Yes. 0 is significant. Next one. 3. Those are my 3 significant digits. Before I finalize, I have to look at the first insignificant digit and compare it to 5. I'm not counting down. Where's 8 with respect to 5?
Higher.
It's higher, which means I need to
4.
add 1. My final answer becomes 30.4 inches cubed. What's that? The 9.8 was what your calculator spits out. That's the slide number. 90 is the slide number. Okay, so a question was brought up in the front of the classroom about the exams. Okay, how many of you have found the practice exam? Okay, about half the class, a little bit better than half the class. Interesting thing about the practice exams, I use the practice exams to write the real exam, which means if you do the practice exam, you will see some of those same questions, the exact same questions on the real exam, because that's a reward for having done what I asked you to do. You get some answers. It's better than that because I'm not very creative, and what do I do to the questions on the practice exam? change the numbers around, change the elements, same type of question, same format. If you understand how and why the question is asked, you have all possible answers or all possible questions for the actual exam. Look at the practice exam. The other thing that popped up, some people have already done the practice exam and this question looks really familiar. They're like, didn't you ask this already? It's like, yeah, it's on the practice exam. I go, oh, well, why'd you do that? Because one of the things you're supposed to be doing in lecture is doing what?
Take notes.
Taking notes. And if you take notes, I should reward you for that. How do I reward you?
The answers.
I put those same questions on the test. Amazing. Okay. Another point was brought up, well, then I'm just going to go through and memorize every question on the slides. Remember that says 90. Okay, so that's 90 slides you're looking at. It's actually closer to 107, I think, for this slideshow. That's a lot of slides to try and memorize. Then you have all the practice exam questions. So that's an extra, for this one, it was like 50 questions that you have to try and memorize. Okay. Feel free to go through and do it. I will reward you for having done that work, but I will not let you just rote memorize. So what ends up happening? I only use roughly 20 to 30% as a verbatim copy. Everything else is an altered version of it. So the strict memorization of those questions will only shoot you in the foot because you're spending time memorizing an answer instead of working on the process. Understand the process behind the question. Any question I throw at you, then you got solved. Okay? If you have more questions about that, feel free to talk to me after class. Okay? So if we get rid of that, how do we determine the volume of an irregularly or non-shaped object? So if we take a look at that little star triangle thingy, we could measure, it's modern art. We'll talk about that in a second. We could go through and measure the volume of each of those triangles and then say, well, I have an oval in here. I can use geometry to calculate all of that, and that's a lot of work. Okay? Chemists are lazy. We don't want to do that. Okay? But that works for maybe that one. What happens with the center one? How do we measure the volume of that one?
You can melt it.
Oh, that's not a bad idea. We could try and go through and melt it. We could put it into a liquid phase, which would be easier. But then what happens to the crown?
Who cares?
You lost it. Okay? And that could be kind of a big deal because the nobility tends to center on having some shiny object to prove that they're awesome. Right? What happens with the last object?
It's just too big.
What am I trying to attempt you measuring the volume of with that?
The inside of it.
I have no idea.
There's no way to solve it.
I'm really trying to get you to measure the volume of that,
The fart cloud.
which is our cloud, which happens to be a gas. Why is that a difficult thing to get an image of?
Oh, I see.
Gases tend to be transparent. We can't measure that easily. Okay? So we need to come up with some way to measure those various objects. Greg, you really like that modern art, huh? Okay. I don't know where it's exhibited. I can Google it. Okay? So how do we determine those volume of the objects easily? Okay? Doing all the geometry is not going to be fun. Melting it destroys the object. How can we measure the volume? So calculus or displacement. So displacement I'll accept. Calculus is easy?
Oh, no, not easy.
Okay, just checking. So let's avoid calculus. Let's do displacement. How can we do that displacement? We can take an object which we can measure the volume of easily, a graduated cylinder, and we can drop our object into that liquid. What happens? The object will displace an equal volume of the liquid, and we now have a measurement of the volume of our sample without destroying it, okay, and without having to do any real hard calculations. What's our hard calculation that we have to do here?
Which one?
The one that I've given you an example of right here. How do we calculate the volume of the jade sample?
You know the volume pre.
60.5 minus 50.0 gets us 10.5 milliliters. We now know the volume. Doing what I would argue is simple math, just a subtraction. Okay? Kind of makes sense? Okay. We can measure gas by displacement. Gas brings in a whole other host of issues. One of the issues with gas is that gases can dissolve in liquids. So that can make this a little bit more difficult. But if we assume the gas doesn't dissolve in liquids, what I can do is do a reaction which will generate a gas. That gas travels up this tube and goes where? Into a closed container. So what happens in that closed container? That gas is now pushing. What is it pushing on? The water, which then gets pushed up through the other tube and deposited out in a device that actually has some gradations on it. I can then measure the change in volume there via displacement.
So the pressure would be consistent?
We run into all sorts of issues. Is the pressure consistent? Theoretically, we would assume it balances out, and it should. Okay? It should balance with atmospheric pressure. Okay? Everything should reach an equilibrium before we start. It should have atmospheric pressure within it. The only thing causing it to differentiate then would be the gas being produced. Okay? We have the issue of the gas potentially dissolving in the liquid. And then we have the other really massive big one. What happens when we heat things up? Remember, take a balloon and gently heat it? It starts to expand. If we heat something up, we increase the pressure, which means we're going to start measuring a change in volume due to heat, not due to the gas. How can we limit that? This heating process needs to be as far away from our measuring device as possible so that by the time the gas makes it over to that chamber, it's cold, okay, or it's room temperature. Okay, so it's just kind of an issue with the experiment of that. But we can still do it. Okay, that's the careful comment. Density. Which weighs more, a pound of lead or a pound of feathers? They're the same. Or as an internet meme I saw, the pound of feathers weighs more because you have to carry around the guilt of having killed that many birds.
Trick question.
Mass is the same. Okay? Why then do we ask this question? Because you ask it to a little kid, they're, the pound of lead weighs so much more. Okay? There's a psychological interpretation that actually turns into a lot larger of an issue that I don't really want to get into, but it addresses our issue of the volume of the object in comparison to its mass, also known as density. Right? When we look at lead, what is the density of lead? It's really, really big. For a very small volume, I get a very large mass. Okay? What about the density of feathers?
Very, very low. Opposite.
It's the opposite relationship. For a very large mass, I need other way around. For a very large volume, I have a very small mass. Okay? So we're looking at the relationship of our density. So one of the aspects on why this question tends to confuse little kids is we don't have a really good perception of density. Okay? As we get older, we tend to get a better interpretation of it, but we still tend to fall back on it's heavier. It's not heavier, it's more dense. Okay? There's more mass in that volume. What is density?
Is how compact the atoms are? Oh.
Mass over volume, also known as, what was that, Emily? No, I don't quite accept that one. DMV, another way to memorize it.
B equals M over V. Yeah.
Conversion factor. I can now convert mass and volume, just like I could convert miles and hours in miles per hour. Density is merely a conversion factor. That is it. Okay? So you then have to be able to manipulate it. Before we manipulate it, what happens with our units on density? Okay, if we look at the first one, ice, which happens to be what phase? Solid. What are our units on the density? Centimeters is just a volume, so that doesn't count. I'll accept centimeters over gram, though it's not technically density. It's the other way around. It's grams over centimeters cubed. Okay. What is our density measurement for water? What is our unit? It's the same. Grams, I don't know why I wrote milliliters. Which, though, technically, does it matter? No, because centimeters and milliliters are the same. Okay. Why do we not see a unit change when we move from solid to liquid?
Because they said from liquid to gas.
Solid to liquid. Why do we not see a unit change? Okay, remember, if we were to draw out a solid, what would it look like? Compact, very little area between them. What happens if we draw out a liquid? Some space, but how much space? Not a lot. So the density changes a little bit, enough to jiggle. Or wiggle. Let's go with a wiggle. Okay, what happens when we go up to water? Or water vapor, which is
The molecules are
the gas phase. And in the gas phase, what happens?
Very separate, very.
All of our particles are very, very separated, which means our volume increases. Okay? So what happens for our unit for density? Does it make sense to still use grams per milliliters or grams per centimeters cubed? Probably not. I'll probably switch to, whoa, come back here. I will probably change the mass unit to being something smaller. Because for a given volume, there's going to be less mass within it. Okay? So I could drop to milligrams or micrograms per milliliter. Okay? So depending on the phase, I may see different units, because what I'm trying to do is make the number in front, which should have shown up, but it didn't, relatively easy to work with. If I kept the grams unit, likely what I'm looking at is something more in the order like this. I'm just guessing here. Do we like a bunch of leading zeros? No, those tend to be confusing, so we can eliminate some of those zeros by changing the unit around. Okay, so we don't have to worry about powers of 10. We can just change the unit, and now the number makes a little bit more sense. It's easier to manage and work with. Okay? How else can we monitor? Question? How else can we monitor these? We could take a glass tube. Okay. Solid 3. What can you tell me about solid 3?
Super dense.
It is super dense, meaning it has
High density.
the largest density value. Okay. Solid 2
Not so good.
has a smaller density value. How do I know it's smaller than solid 3?
Because
It's on top of it. Okay? It's staying above it. That's how we know. Which is more dense, solid 2 or water? Solid 2 because
It's sank to the bottom of the water.
it's at the bottom of the water. Okay? So by drawing out a diagram, we can interpret their individual levels, and we can come to a better understanding of what's happening within them. If we take a look at our volumes, our densities, we can see that we have slight adjustments on our units when we move up into the gas phases. And I shifted the wrong direction with it. Okay? Do you need to do a unit conversion? Yeah, we do. Do it. Okay, I want to know what the density of a platinum nugget that has a mass of 224.5 grams and a volume of 10.0 centimeters cubed. Okay? And just because you guys seem to be pretty good at it, we're just going to skip the grams per centimeter cubed. You're going to go straight to units of pounds per liter. Okay? That's the density unit I want. Set it up, see what you can come. Oh, we need to figure out where to start. Where do we start? Every single time. And I'm still getting people asking this. I don't know where to start. Okay? Where do you start every single unit conversion? What you want equals lead. That's not lead. Pounds over liters. Okay? What's the next thing? What we're given. I'm given grams, I'm given centimeters cubed, I'm giving pounds, I'm given grams, I'm given centimeters cubed and milliliters. There's a lot of things I'm given. Which of those things that I'm given do I want to start with? Right. Why did you pick grams and centimeters cubed? And I'm not saying you're wrong, because that works. Is grams pounds?
No.
Is centimeters cubes pounds? Is grams liters?
No.
Is grams centimeters cubed? No. Okay, so you picked two things that can eventually work for you, but why did you pick them? Just because you're given them doesn't help you decide where to place them in your calculation. What do we know we need to start with or end with? Pounds and liters. So why don't we pick something that has one of those units in it? Okay. And we could try and do a mass volume, but that's an extra interpretation. Let's just pick something that starts with pounds. What thing has pounds in it?
The conversion of pounds to grams.
1 pound to 454 grams. Where does the pounds need to show up? On the top. Why do you say on the top? You look at your answer, where does it need to show up? On top. So I need to put pounds up here. What do I put underneath it? Grams. Because that is the conversion factor. 1 pound is 454 grams. Where do I put the 1? I disagree with on top. I disagree with on bottom. I put it with pounds. Why? Where is the 1 associated? With pounds. If you start using 1 on top or bottom, what you'll end up doing is misplacing it later on. The number's associated not with top and bottom, it's associated with the unit. Where does the 454 show up? With grams. Good coverage. Cool. I've now got pounds in the numerator, which is exactly what I want. But I've also introduced this nasty little gram thing. Do I want grams in my answer? No. What do I need to do? I need to get rid of that gram unit, right? Okay. I heard a couple people saying convert grams to liters. Liters is a measurement of volume. Grams is a measurement of mass. Do we have a mass volume conversion?
Yes.
Once we have a density, we do, but we aren't given a density. Okay. The question of can we solve for the density is a separate topic. We're not given the density. What are we given about the grams? Am I given any information about the grams of this sample? I have 224.50 grams. Why did I place that in the numerator? I want my units to cancel. What do I put in the denominator? I heard a couple people say nothing. Okay. 254.50 grams. Okay. If I put any number underneath that number, let's say a 2 here, okay, or what some people I believe were suggesting, say 10. Is it now 224.5? No, I've changed the meaning of that number. What number must go in the denominator so that I do not change the meaning of 224.5? 1. If it's 0, we don't want to open that one. That's a mathematical
Nightmare.
yes. Okay, what unit? No unit, because if I put in any unit, is it 224.5 grams anymore? No, it would be grams per something, so I can't put a unit there. 1 represents just that part. It's acting as a placeholder to make sure that we don't place anything in the denominator. So cool, I've fixed my solve. I've gotten rid of grams, and I've brought in pounds. I now have my answer halfway. I've got pounds in the numerator, but I don't have liters in the denominator. Okay? So again, I need to find somewhere in the question that liters has shown up. Am I given liters anywhere? What do you mean?
Centimeter cubed, so if you get that, you know,
I don't directly have liters, but unfortunately, what am I expected to be able to know? How to convert liters into a variety of other units, one of them potentially being milliliters. Where do I want that liter conversion to show up? Where does that unit need to be? Why does it need to show up in the denominator? We look at the answer. Where does the answer have liters? In the denominator. That's why liters shows up there. Am I given liters explicitly? No. So I'm going to have to convert those liters to something. What do I want to convert those liters to? And this is my choice. I can convert it to anything I want. I can go to deciliters. I can go to hectoliters. Why do I want milliliters?
Because you're trying to figure out a centimeter cube.
You're starting to process and see what the next few steps are going to be, which is good. Okay? What is the conversion between milliliters and liters? Okay? And I keep hearing the 1,000 milliliters. I have a problem with that. Milli means thousandths. The power of 10 goes with the core unit. Okay? I'm trying to be consistent in this calculation. Okay? Do I have my answer? I have pounds times milliliters divided by liters. That's not what I want as a final answer, so I'm not there yet. Yeah.
Does it work too if you put on top with the milliliters 10 to the third power and on the bottom 1?
Yes, the reason I'm not doing that is that confuses what milli means. And so it's a use of the definition. Okay? And if you switch that definition, you often make a mistake when you shift to kilo.
Or would,
Okay.
that would be wrong.
It's not wrong, it's just propagates mistakes. Okay? So I'm closer. I've got liters in my denominator, but milliliters is in the numerator. How do I get rid of the milliliters? Just ignore that. I didn't ruin anything. Okay? Ideally, I would have milliliters as a value. Am I given milliliters anywhere? Not explicitly. But I have milliliters that I could convert to centimeters cubed. What is that conversion? 1 centimeter cubed is 1 milliliter. What is my unit? Pounds times centimeters cubed divided by liters. Not quite there yet. What do I need to get rid of? Where does the centimeters cubed need to show up? In the bottom. Am I given a value that has centimeters cubed?
Yes.
Yes. I can now put that value in. What do I put on top? 1. Okay. Because if I put in any other number, that changes the meaning of the 10.0 centimeters cubed. So what we're including in each of those little sections, or train cars, if you will, okay, is a single conversion, okay, a defined value. We are not combining steps. The instant you combine steps, you increase the likelihood of making a mistake. That is on you, not on me. Okay? Because I'm showing you how to break it down. What happens when we go through and process this all out? The unit we end up with is...
Would you multiply all the numerators and then multiply all the denominators?
So now mathematically, how should we solve this? Okay? I find the easiest way to do it is take everything in the numerator and multiply it out and get a number. I will then take everything in the denominator, multiply it out, and get a number. Then what will I do? Now I'll do the numerator divided by the denominator, and I'll have my final answer. Okay? This is the accepted process for going through and solving this. I've seen lots of people going through and trying to solve each of those steps independently. You are welcome to do that. The issue with solving it independently is you increase the likelihood of making a mistake because you're now just saying, well, I need to divide by this or multiply by this. If you write it out, the numbers fall according to where the units are, not according to where you want to multiply or divide. This process sets up the math, not the other way around. Okay? Which is confusing because what does math teach you, or mathematics classes teach you? At least some of them. I hear we're better here than other places. Math tells us that numbers come first, which is a load of crap. It's all about the units. Okay? Probably write a song about that. Okay? That said, if there are questions, you can ask after class, so I will get back to you. I do want to address one more thing. I went a little bit slower than I had planned. I can't go back to the writing. It's all erased. There are 2 topics that were missed. Temperature. Fun thing with temperature is we have conversion factors to convert between the 3 different types of unit systems that we set up with. Okay? There's a bunch of conversions. We also have heat as a concept. And heat and relationship to temperature are not the same thing. These are concepts that were not covered, which means they aren't on this test. We'll shift them to the next test. That said, if for some reason I decide to include them, what will those questions become? Extra credit. Specific heat is one more topic that isn't on the test.
There will be questions from the English class.